In the world of quantum, IonQ is a US quantum computing company, and they are buying the UK-based Oxford Ionics. Strange, there's lots of ions going on. Deal's worth $1.08 billion, first billion-dollar deal in the quantum computing industry. The goal is to combine IonQ's powerful quantum systems with Oxford's chip-based technology, which is much easier to produce at scale. The move helps IonQ advance its plan to build large, reliable quantum computers by 2030, and the deal also boosts IonQ's position as a leader in the growing quantum tech space. Tom, we talk quite a lot about quantum, and particularly around when quantum computing is going to be big enough and reliable enough. Do you think 2030 is a realistic goal for IonQ?
I think it is. I just don't think that what they're going to be selling is going to be very cheap. And the reason for that is because the amount of effort that's going to go into building a quantum computer out of these components, there's a lot of inputs to it. So the short version for all of you out there that are wondering what the heck is an ion quantum computer, they essentially take ions, just little elementary particles that have a charge, and they stick them in a field. And effectively, what they're doing is they're using electromagnetic spectrum to trap these ions in this field. And then they supercool the whole thing to just a couple of degrees above absolute zero. So far, so good, right? Well, then you have to manipulate those ions to be able to get data out of them, right? Like any traditional computer would. And you do that using this complicated thing known as a laser. And so the problem you run into is, one, the inputs cost a small fortune because the amount of, things like liquid helium that you have to use to keep these things super, super, super cold, but also the complexity of the way that the lasers need to interact with everything makes it a lot more difficult to just kind of spin one of these things up. And I mean, we've seen that with a lot of quantum computing, even I say startups, but like Cisco started a quantum computer lab out in California. And one of the things that's a big problem is the fact the amount of power that they have to pump through those lasers is, well, frightening when you think about it. But ultimately what this means is that these two companies realize that in order to bring something to the market for them to be able to get a return on their investment, they're going to have to examine how to make this cheaper and more reliable with less precise inputs. And think all the way back to the late 18th century when Eli Whitney invented interchangeable parts. Back then, anything you made was custom built. And that meant that whoever built it needed to be very, very good at what they did, right? So if it was a hunting musket or any kind of like a steam engine or anything like that, it was all custom built. And that meant whoever built it had to deliver it and had to assemble it. And it was a pain in the neck. But with interchangeable parts, I could just say, okay, take 3 of these and 2 of those and put them together like this, and you can make a thing. Quantum computers are kind of where we were back then, where everything is kind of custom and bespoke. If they're going to make this more of a, marketable thing, they have to make it so that maybe not you and I, but somebody can build one of these without needing to have like all of this kind of crazy training to make it work. Can they do that in 5 years? Well, honestly, I don't know. 5 years ago, if you'd have told me that people would have even had quantum computers capable of what we have today, I would have probably wagged my finger at you. But the point remains that there is a large gap between something that is available for sale and something that is available for sale cheaply enough where everybody can buy it. I think what we're going to see is that IonQ and Oxford Ionics are going to figure out how to make a cheaper quantum computer. That doesn't mean they're going to make a cheap quantum computer. I still expect this thing to cost multiple millions of dollars to put together. But even at multiple millions of dollars, it puts this kind of technology into a space where large organizations that potentially could need that can buy it and use it, as opposed to having to farm time out on these large systems that are effectively backed up for months or years at this point, because it's the only game in town if you want to do those kinds of things. So we'll keep an eye on it. I mean, it is big that it's a billion-dollar acquisition, but billion-dollar acquisitions also have to produce results if you want to pay off in the long run.